This is Geometry, Chapter 0, Section 8, in which we will be solving systems of linear equations. All we're talking about with a system of linear equations is a group of equations in the same variables, typically x and y, but they could use other variables. Typically, though, you'll see x and y. There are three main weapons that we can use to solve these things, and we're going to get to practice all three of them today. There's the graphing method, the substitution method, and the elimination method. So we'll look at each one in turn. First, the graphing method. They're going to give us a couple of equations and they want us to graph them. Well, in order to graph them, we need to pick some values for x. And I'm going to pick -1, 0, and 1. If I plug in -1 to the first equation, opposite of -1 is 1 plus 3 is 4. If I plug in 0, I get 3, and 1, I get 2. In the other equation, I'm going to use the same three values, -1, 0, and 1. 2 times -1 is -2, minus 3 is -5. If we plug in 0, we'll get -3. And if we plug in 1, we get -1. Now we can graph those two lines, which I've already done for you. And we can see that they intersect at 2, 1. Now sometimes when you graph these, you get parallel lines. In that case, you would report no solution. If the two lines are the same line, they graph right on top of each other, then what we would say is infinitely many solutions. So that's the graphing method, probably the most straightforward of the methods. The second one is the substitution method. So they've given us two equations, x plus y equals 6, and 2y plus 3x equals 10. The first step is to pick one of the equations, and I picked the top one, and get one variable by itself. I chose y. The reason I chose the top equation is because I wouldn't have to divide by anything, so I don't have to carry around fractions. So subtract the x over, we get y equals 6 minus x. Now take that value, 6 minus x, and plug it in place of the y in the other equation. So I'm going to take the y out and put the 6 minus x in its place. Now this is an equation I know how to solve. 12 minus 2x distributing plus 3x. Collect up terms and then subtract the 12 and I have a value for x. Now I can take that value for x and plug it back into what I had y equal. And it turns out y is 8. So the solution is -2, 8. Whenever you're using a system of equations, and it doesn't matter which method you use to solve it, you're ultimately finding a point. So you need to report your answer as coordinates. Two methods down, one to go. Now we have the always popular elimination method. This is the one that most people seem to like the best. Okay. The goal of elimination is to pick on one of the variables to get rid of it. We can either try to get rid of the x's or try to get rid of the y's. Either one, it doesn't matter which one. You're going to want to make the two numbers the same value with one positive, one negative. So I would either need to make these both into 12s, because 3 and 4 go into 12, or these into 10s, because 2 and 5 go into 10. Well, I chose to work off of the y's. You could do the x's, you get to the same result. You'll notice I put a negative on this one so that I would get a negative 10y to go with this positive 10y here. I could have put the negative on the 5, it really wouldn't matter. I just put it on the top one. So distributing the negative 2 and the 5, you get negative 6x minus 10y equals negative 14. And I get 20x plus 10y equals 0. Now I can combine these two equations together, and look what happens. The y is gone. Just by simple addition, and then divide, and we get x equals negative 1. Now we take that negative 1 and we can plug it into either one of these two original equations. I picked the bottom just because. No special reason. So plug the negative 1 in. Clean that up, and that gives us negative 4. We'll add the 4 to the other side, and we get y equals 2. So just like I mentioned on the last page, we need to report it as a point, negative 1, 2. Okay. 3 methods: graphing, substitution, and elimination. And they're going to ask you to do some problems with each of the 3 methods. As always, if you had questions, I hope you jotted those down so you can bring them in, and we will see you in class.